In 1928, penicillin was invented. It was used as a treatment for bacteria, and it seemed like the cure-all for any bacterial infection. Thus, we used it extensively to treat anything we suspected as a bacteria. We need to look into new ways to treat bacterial infections as antimicrobial resistance is on the rise. Over the last month, I have been researching this topic extensively, and as well as writing a research paper on it. For everyone, we have likely come in contact with antibiotics, whether we use Neosporin on a cut or used a pill to treat an infection. Bacteria are becoming resistant to antibiotics more every day. You may wonder where antibiotic resistance began, problems they cause, and how we can fight this epidemic. What causes antibiotic resistance? Bacteria divide through a process called binary fission. This is when the bacteria replicates its DNA and grows large enough to separate into two daughter cells. Microevolution is another process of when these imperfect DNA replications from binary fission cause new traits to arise. For example, if we were to give blue circles normal bacteria and red circles the mutant bacteria with the new strain through microevolution, we can see that in our first generation we have 1 mutant bacteria. In the third, we have 4, and in the fourth generation, we have 8 total mutant bacteria. Because of this, let's say that our mutant bacteria developed a resistance to antibiotics. This would be dangerous to our public health because then this bacteria is no longer treatable. The bacterial STI gonorrhea is showing some resistance to penicillin, which is very concerning. The very first instance of antibiotic resistance was recorded in a Staphylococcus aureus strain that showed penicillin resistance. Another staph strain became resistant to methicillin. This strain is known as MRSA, or methicillin-resistant Staphylococcus aureus. If a person were to have a systemic infection, which means the infection gets into the bloodstream and moves throughout the body, there would be a much higher chance of dying from this infection. Understanding the background of antibiotic resistance is crucial to understanding its problematic nature. Every single day, our body is fighting bacteria, viruses, parasites, everything. When a bacteria gets inside our body, our white blood cells work endlessly to fight off those bacteria, aside from the natural flora inside our body. Because they fight every day, they continue to work. Imagine if a bacteria, an infectious bacteria, grows large enough in your body that they stimulate the immune system, causing you to feel ill or sick. And let's say this bacteria developed a resistance to antibiotics. Some of the antibiotics that are prescribed to you to treat those infections may end up being useless to fight it. So these strains will continue to grow and continue to make you sick. We can never get rid of bacteria. We even use some bacteria in our body so we can survive. This is known as our natural flora. When we die, all of our bacteria live on. When we use antibiotics, we often overuse them and misuse them. For example, if you came down with the common cold or the flu, which are viruses, antibiotics do nothing against them. When we use antibiotics on stuff like that, they will damage our natural flora and they will cause us, it'll make our body have a much harder time fighting the infection. According to a journal article titled "Combating Antibiotic Resistance, the Role of Nursing and Antibiotic Stewardship," published in the American Journal of Infection Control on December of 2016, states the United States used almost 8,000 tons of antibiotics in 2010. Antibiotics are being overused in livestock. These uses are problematic because the bacteria that survive the abundance of antibiotics trickle down to the consumers like us. Pesticides also work in the same way, as vegans still have food problems when their produce can have chemicals on them. Because this is why we must wash our fruits and vegetables and cook our meat thoroughly. When bacteria are untreatable, they cause devastating events. They increase healthcare costs, like the US isn't expensive enough, increases patient suffering, and increases mortality or death from the infection. These dangers are only becoming more common. How can we stop this antibiotic epidemic? According to an article posted to nature.com titled "Why Big Pharma Has Abandoned Antibiotics," posted on October 21st, 2020, stated that the cost of developing an antibiotic is roughly $1.5 billion with a big B, while the revenue from those antibiotics are roughly 46 million M. Pharmaceutical companies also favor cancer treatment drugs over antibiotics due to the increased revenue. A safe solution that is overlooked are bacteriophage. Bacteriophage, or phages, are small viruses that only attack bacteria from a particular species or closely related species. Here is a bacteria. It consists of a head, a body, and legs. These legs attach to a bacteria, and then the body will inject the DNA from the head into the bacteria. And this DNA or RNA could either replicate more bacteriophage, or it could lyse the bacteria. And there's also other ways this DNA could affect the bacteria. When we use antibiotics, we use them to treat the infection, regardless of what bacteria it is. If, let's say, we have our good bacteria represented as blue circles and our bad bacteria represented as red circles, antibiotics will kill anything that it can get to. So it can end up killing a lot of the bad bacteria, but it can also harm some of the good bacteria, like our natural flora in our body. But if we were to use bacteriophage, the bacteriophage will go out and seek every single bad bacteria it can find. And when it does that, it'll treat the infection. If a bacteriophage comes into contact with a good bacteria, they will bounce off and carry on. A study was completed about phage effectiveness. It was titled "Phages Amid Antimicrobial Resistance," published in Critical Reviews in Microbiology on November 27, 2019. The study displayed that when a rat was infected with MRSA, they were given a bacteriophage cocktail that resulted in a 100% survival rate and bacterial clearance. Humans also had positive results. Patients who had a bone or joint infection were given a phage cocktail that cleared the bacteria at the site of the infection. With all this positive information, you may wonder why they aren't used. Bacteriophage have a narrow host range, as I showed you through this diagram. It also is difficult to isolate the phages needed to treat any infection. Knowing the history and prevalence of bacteriophage, bacterial resistance, helps us understand why it is a problem and how we can deal with it in a productive way. Antibiotic resistance is a huge and growing threat to public health. We must find new ways to treat bacterial infections, or else we will experience outbreaks similar to COVID-19 in our lifetimes. Whether you continue to use antibiotics or you want a new solution, we must turn the tide on the war against infectious bacteria. Thank you.